Okay, so now it's time to look at some exam-style questions. Firstly, this one says, using the graph, what is the pre-exponential factor, A, for the reaction from which the data was collected? And then we're given a graph that you should be familiar with from the slides of lnk on the y-axis and 1 over temperature on the x-axis. So as we've just said on the previous slide, the intercept gives us the natural log of the pre-exponential factor, A. So going back to the equation, because we want A, we're going to look at the intercept and read that off 24. And then we're going to use the inverse natural logarithm to get back to our value of k. So we know that the inverse natural logarithm, e to the power of 24, is going to give us our answer. If we type this into our calculator, we find that the answer is 2.64 times 10 to the 10, and that is given to us by D. And then that is where we get our 1 mark. Now if we come down and look at the next question, it tells us that the iodine clock reaction is carried out twice, at different temperatures, with all concentrations and volumes kept constant. Here we have a table that summarises the data collected, and then the question says, without drawing a graph, calculate the activation energy of the reaction, remembering to give a sign and units with your answer. It then gives us the useful form of the Arrhenius equation, where the logs have been taken, and gives us the gas constant here. So although it tells us not to draw a graph, we know from this equation and from looking back to our slides that the gradient of a graph is what gives us the activation energy. However, they've only given us 2 data points, and that's why there's no need to draw a graph. If you think about what that would look like plotted out, you'd have the first data point here and the second data point here, and then the line would go through them. If we're interested in the gradient of that line, we're just thinking about the change in y and the change in x. There's no need to draw a graph for this, we can calculate it mathematically. So the gradient of the graph we would be interested in is given by the change in ln rate divided by the change in 1 over the temperature. When you're doing this, remember that we're only interested in changes, and the rate is directly proportional to the rate constant. So that's why we're just using the rate here rather than lnk, which we've been using throughout. So you should remember from our video on clock reactions that 1 over time gives us a measure of the rate. So what they've given us here, ln 1 over time, is actually ln rate.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today, and together let's make A-level chemistry a walk in the park.